Homework 19, Basic Principles of Hypothesis Testing, Video 1. This is the first series of videos or content that will be covered on your final exam. There will be 3 series of videos and hence 3 homework assignments. Although it's new material, I personally think it's pretty straightforward and the homework assignments are fairly short once you wrap your mind around the concept. So let's begin. We're going to start by defining what I mean by hypotheses. And just for the record, when spelled with an ES at the end, it's plural. When spelled with IS, it's singular. Now you've heard the word hypothesis before, probably in a science class. And if asked to define it, you would probably say that a hypothesis is an educated guess. But in the context of statistics, it has a slightly different definition. In statistics, a hypothesis is a claim about a population parameter, emphasis on the word population. You never make a hypothesis about a sample, because a sample you can measure completely. If you take a sample, you can calculate its mean. You can calculate its standard deviation. Or if it's a sample from qualitative data, you can calculate the sample proportion. But for a population, populations are usually too large or too dynamic to accurately measure any of those things. And therefore, we can never actually measure a population in most cases, but rather make a claim about them and then find evidence to either support that claim or refute that claim. So again, a hypothesis is a claim about a population parameter. For example, somebody may claim that in a population, the mean is 37.5. Mu equals 37.5. This is the claim about a population. I claim its mean, its average is 37.5. Or I may claim that in a population, P is equal to 0.75, meaning that 75% of the population has a certain characteristic. Or you can even make a hypothesis, a claim about a population standard deviation. I claim the population standard deviation is 1.2, whatever it is we're measuring. But the important thing is that it's always about a population. It's never about a sample. Now, don't get me wrong. We're going to use samples in hypothesis testing, but in terms of writing a hypothesis, it will always be about a population. So that means it's not about X bar, it's not about P hat, and it's not about S, which are the point estimates for these population parameters. Sample mean is a point estimate for population mean. Sample proportion is a point estimate for population proportion. Sample standard deviation is a point estimate for population standard deviation. And again, we will be using those point estimates. We will be using an X bar or a P hat, and if we were doing it for standard deviation S's, as part of the hypothesis testing process. But as far as a hypothesis goes, it's just a claim about a population parameter. Can't stress that enough. Oh, by the way, it doesn't always have to be equal. For example, let's go to the second one here. I may claim that the proportion of a population that has a characteristic is not equal to 75%. So it could be not equal to. That's still a claim about a population. Or I could say that the standard deviation is greater than 1.2. That's still a claim about a population. So when you have a hypothesis, it's always about a population parameter. So for our purposes, mu, p, or sigma. And it can state equality or inequality or some other relationship, such as greater than or less than. Now, within the realm of hypothesis testing, there are 2 types of hypotheses. The first type is called a null hypothesis. It's abbreviated H subscripted with a 0. I do understand that this looks like a letter O, and hence this looks like something that might make you giggle. Get over it, because you're going to see this abbreviation a lot. But a null hypothesis is a hypothesis that claims a parameter is equal to a value. So of the 3 hypotheses I have up here, only one of them could be a null hypothesis. That would be this one. It's the only one claiming equality. To write a null hypothesis in the context of hypothesis testing, you would write the abbreviation for it, followed by a colon, and then your claim. So in this case, we're claiming that mu is equal to 37.5. It's important to point out that H0 is not a variable. You never say H0 equals something. It is simply an abbreviation for the phrase null hypothesis. And again, the correct notation for writing a null hypothesis is to say H0 colon, then write your claim about the population, provided that claim says equals. So null hypothesis always, always, always includes an equal sign. Now you may have noticed there's an asterisk here. Full disclosure, especially if you plan on pursuing a degree that involves more statistics. In some textbooks, the definition of the null hypothesis doesn't restrict it to saying the parameter equals a value. Many books, in fact most books, allow it to say greater than or equal to, or less than or equal to. But the consistent thing across all statistics books is that the null hypothesis always allows for the possibility of being equal. In our book, it will strictly be equal, but in other books, it could be greater than or equal to, or less than or equal to. The other type of hypothesis, and it's worth mentioning that they always occur in pairs, is an alternative hypothesis, abbreviated H1. Again, a comment in some textbooks it's abbreviated HA. In this textbook it's abbreviated H1. An alternative hypothesis is a hypothesis that claims a parameter differs from the value claimed in the null hypothesis. So an alternative hypothesis is always paired with the null hypothesis and vice versa. The alternative hypothesis may contain one of three relations: is not equal to, is greater than, or is less than. So you can tell that the three options for the relation in an alternative hypothesis do not allow anything to be equal. Either you're flat out different from, aka not equal to, or you're greater than, or you're less than. So of the three hypotheses I wrote up here, two of them could be alternative hypotheses. The second one, which says P is not equal to 0.75, looking for my blue marker. This, if it were a hypothesis, would have to be an alternative hypothesis, so we'll put H1 here. Population proportion is not equal to 0.75. Now there's a reason I left a blank above this one and a space below this one. The third hypothesis, in our first example, is that the population standard deviation is greater than 1.2. Since that contains a greater than sign, it has to be the alternative hypothesis. And more specifically, since it doesn't allow this to be equal, it can't be the null. So we could say the alternative hypothesis in this case would be that sigma is greater than 1.2. Now the reason I left some space, a space below this null hypothesis and above these alternative hypotheses is because, as I mentioned, hypotheses always occur in pairs. A null and a corresponding yet contradictory alternative hypothesis. So for example, if we use the author's definition of null hypothesis in this book, and we will, the null hypotheses for both of these simply have to say equal. So the null hypothesis for this first alternative hypothesis would have to be P equals 0.75. Whereas the null hypothesis for the second alternative hypothesis down here would have to say sigma equals 1.2. And again, for full disclosure, especially those of you that are going into nursing and medical areas, you may be required to take more statistics classes. In a lot of statistics books, the null hypothesis could be one of these two symbols as well. In this book, they're restricting it to equals. I want to go back to the first null hypothesis I have written, that the population mean is equal to 37.5. Without context, there's no way to know what this alternative hypothesis could be. The relationship between the two hypotheses is pretty straightforward. One of them says I'm equal to, the other one says no, but could be one of three things. So if you're not given the alternative hypothesis, you really have an option of one of three things. However, in all the problems in your homework, you'll either explicitly be told what relation to use in the alternative hypothesis, or the context of the problem will dictate not equal to, greater than, or less than. For variety, let's use the one relation we haven't used in an alternative hypothesis yet. That would be less than. I claim the average age of people who work at a company is 37.5 years old. We took a sample that had a lower mean, so we're contradicting your claim about the population. We claim that the percent of people who have seen Game of Thrones is 75%. Well, we took a sample and we got something totally different, so we claim that it's not 75%. And then the same thing for standard deviation. The idea behind hypothesis testing, and we're going to go into much greater detail in subsequent videos, is fairly straightforward. Somebody is going to make a claim about a population. A sample will be taken that will contradict that claim. Based on the sample's result, the alternative hypothesis will claim something different about the population. Either less than what you claim, greater than what you claim, or just flat out not equal to what you claim. And then there's a procedure to determine whether or not that sample provides strong enough evidence to reject your initial claim and accept another one in its place. So it's going to be a battle between, is the sample strong enough to reject your initial claim, or is it not strong enough and we don't reject it? All right. In the next video, we'll talk about the different types of tests that we're going to conduct. They're all the same tests. There's just one place where you have to make a subtle decision, and that subtle decision is based solely on the alternative hypothesis.